Cool. So yeah, you read my comment, and what are you thinking?
Yeah,
I kind of
yeah,
just wrote it, so I don't know if you've read all of it.
yeah, I read it. So I kind of agree that GitLab.com is a special case. And the big question is, should we come up with a solution that works everywhere, right? Like self-managed and GitLab.com and I don't know where they host GitLab, or handle GitLab.com as a special case and have generalized helper for everything else. That's a big question.
Yeah, I agree. That is, I'm trying to think of like the best way to tackle these kinds of really big problems without getting derailed by solving too much at once. So like one, I'll just share my screen because I just edited the comment, which you may have like not seen this point. But one thing I was thinking is, okay, we discussed in our meeting the other day that the challenging problem we want to solve is how do we migrate all of the CI tables at once. We aren't planning on doing these one table at a time. And maybe in the next 6 months or a year, we're only going to do one big migration that will be all of the CI tables. And there won't be another migration that comes and we go, okay, we're going to do another table now. And won't be that won't happen for a long time. So maybe it's better to avoid trying to solve the problem of like, all right, how do we build a set of tooling that moves tables in a generic way, and think about the specific problem we have to solve. And I kind of thought maybe then the thinking about it in terms of migration helpers might not be architecturally where our head needs to be. Because if we think migration helpers, it's probably going to be a little bit anchored to what we have now in terms of, yeah, they'll be, I mean, your comment didn't necessarily suggest that, but they'll be similar to the other Rails migration helpers we have, and people will write them in helpers like that. I also don't even know that practically thinking that way will be how we'll technically execute on it in production, because we have this weird thing where we want to like migrate things at a controlled time and not just when we deploy. We're not going to want to migrate our CI tables to a new place just when we deploy, but we're going to want to say, we're going to merge the code, it'll be in there, and anybody in development for maybe months at a time is running with multiple logical databases while we are building out this migration plan to move the CI tables, in a similar way to the fact that like GitLab.com supported Postgres 12 many months before. I mean, GitLab, the code base and the development environment, supported Postgres 12 well before we migrated. So yeah, all that to say is that, yeah, I don't know if migration helpers is how I'm thinking about it right now, but do you have any thoughts?
Yeah, so but to be honest, we still need, so if we're thinking about zero downtime, we still need to do some work on the application side to support it, right? So if so for some magic happens and the data pops up on the other database, it's migrated, it's there, it's up to date, we still need to figure out how do we make the switch to the new database without downtime. So it's not just infra, but we will also have to invest some time to figure out the backend part of it. How will this actually work without downtime?
Agreed, and we can go into the specific ones of that too. Another thing I kind of wanted to address that you said before, which was about self-managed, and I think a way to think about it might be, let's not constrain ourselves right now to the problem of, okay, how do we ship a migration plan to customers or an automated migration technique to customers? And let's go, if we can run a manual set of processes ourselves, we can write down a game plan for ourselves, then we can write down that same game plan to self-managed customers, as long as we can make sure that the application keeps working for them if they don't execute on that manual game plan for a long enough period of time, give us time to implement the automated thing at some point. And maybe like, let's just arbitrarily say 15.0 will be the cutoff when you have to have executed some approach to migrating your data. Yeah, anyway, okay, cool. So then the thing you said before about what the application has to know about it, I was thinking Right now, the application uses service discovery to figure out what is the primary and what is the secondary for databases it connects to. So I have had a couple of ideas of like the application could be abstracted from all of this happening if the application uses service discovery and all of a sudden finds out that it reads CI data from a different host, basically. So the first logical step in my head is like the application understands it has two different connection pools. One is for normal tables and one is for CI tables. And it understands that it reads those things independently from service discovery, which is console. That's the first step. But initially, console or console in this case is just pointing it to the same host. And maybe the same thing with a YAML file configuration. By default, they're just going to be going to the same host. Something then orchestrates a kind of failover, which then changes the primary for the CI tables to point to a new host that is now no longer a secondary for, this is kind of getting into how I imagine it might work with Petroni, but it was previously a replica secondary database and therefore has all the CI tables updated. The failover happens and now it's the primary for CI only, but they now have two different primaries, they're different hosts. That was one way I was thinking about it. The other way I was thinking about it is a proxy model, which I think is another way to keep this out of the application. And a centralized proxy also affords us easier ways to solve the locking problem. The locking problem, which is totally valid, which you mentioned up here, is like if we have the application just writing from Ruby code to these tables, it's very hard for us to orchestrate a lock without us wrapping every place that we write in the code to these tables in some way.
Yeah. So I like your idea of a proxy. So I think what you mean is that there's a proxy before PG browser, before the databases, and there we add the logic to actually at some point, okay, if we are querying the CI tables, instead of sending the query to this socket, just send it to the other database via another socket. I guess that's
right. But also importantly, it could block writes for a period of time.
Yeah,
because we know that a failover will require a write downtime. As far as I understand, this is what I didn't get to today, was actually fully understanding how Petroni works. But I assume that a failover requires write downtime, and so the proxy could implement that, and we could therefore go, we don't need to update every part of the Rails application to acquire locks and so on and so forth.
Yeah. So I had another idea. So actually, we might not need to lock anything. We might not need to change anything in Rails. We just need to extend Rails a bit. So let's say your data in both databases is kind of up to date. Maybe not 100%, but almost. So at that point, when you say, okay, now I'm going to switch, you can acquire an exclusive lock on the original table, right? And that blocks all the writes, all the queries, everything. And what you can do is you have the exclusive lock in your transaction. You sync the remaining data. You make sure everything is up to date. You do, I don't know, calculate some hash code, whatever. And what you do is you set a trigger to stop, to prevent writing to the original table. And that will, and you commit the transaction. And at that point, the other transaction, other queries that are waiting are going to fail. And if you catch this failure at a low level, you can actually retry it. And if you detect a specific error, we can say, okay, if this error happens, then try to reconnect again, get the latest IP from console, and it's just a database reconnect and everything returns as normal.
Okay, so yeah, that makes a lot of sense. So in that transaction, which is going to start queuing any writes to the table, we will, before closing that transaction, we'll create a trigger, which therefore makes every write that's in the queue fail, and presumably read too, because if we're switching, we don't even want them to read there.
Yeah, I mean, what you can do, you can even rename the table in the same transaction, and the table is there, and then it will just fail because the table is not there yet, not there anymore.
That makes sense. Yeah, the one thing that's coming to mind is that that solution involves queuing reads, right? Which is not ideal.
Yeah.
And that will limit significantly what we'll be able to do in terms of, it'll create much larger user impact than something that limits writes only for the switchover period.
That's true.
But yeah,
that's
the only thing that comes to mind. It really depends on use cases whether or not, like if we're talking about CI, pausing writes is going to be really problematic for a lot of parts of the CI system as well anyway. So it's not necessarily like if we were pausing writes to issues, for example, it's, for 5 minutes, users could probably live with that and not really be hugely affected. Like pausing writes to CI might be seriously problematic for all the times where we need to create a pipeline and so on and so forth.
So I'm not thinking about locking or blocking stuff for minutes. That's simply not gonna work. So I am thinking about less than the statement timeout. So it's less than 15 seconds. We should be able to do this.
Right.
And of course, on peak hours, you are not gonna migrate it because there are so many traffic on the table. Getting exclusive lock is a problem there. And also the replication between the two tables might be way behind. So it's usually should happen quiet periods, right? And where you have not too much lag. And then I would imagine we could do it in a few seconds.
Yeah. I guess that's the experiment we'll actually need to run with any one of these like catch up, synchronize and catch up approaches, is what does the catch up window look like depending on, the time of day. Because acquiring the lock will take, so what will happen is when you go, we'll say, okay, we're pretty well caught up. Like we're pretty well caught up in our stream. Now let's try to acquire that lock. And there will be this window of time before we ask to acquire that lock, that will start the clock for the catch up period from there on out.
Yeah.
And however long it takes us to acquire that lock, all the updates that have come in that point in time is now our catch up writes. And yeah, we just will need to figure out what timing we can actually get that down to. And so we can get it down to a few seconds, then a lot of things become a lot easier. But so then we talk about if we queue, a benchmarking thing to figure out is queuing reads or just queuing writes, what the implications will be. Because let's say we have 100,000 writes, but then like 10 million reads, like in that window of time, it'll become quite apparent that we really want to not queue reads, because those reads then sit in front of all the writes that need to happen, or they're just this huge volume of data that needs to get sent to the new host as soon as it comes back online that we could have handled.
I get it. So the others, we can extend this solution. So if you assume that most of the data is up to date in the secondary, in the new database, right? Then what we can do is execute the reads as how do you say, not skipped locked, but so basically if the select statement cannot acquire the lock because there is an exclusive lock by another thread, it will fail. In that case, that failure can be retried on a replica, and then the reads would just go through. And anyway, most of the reads are gonna hit the replica anyway, and exclusive lock on the primary is not going to affect that.
Oh, that's interesting. Yeah. Okay. And really, this is just kind of a weird, like us doing it that way is kind of just hacking around the fact that there's no way for us to ask for a lock that is only like lock this whole table, but only for writes. Like it just still allow anybody to read anything they want from that table.
I'm not sure. I'm not super familiar with the different lock types in Postgres. But I don't think there is something like a lock to lock the modification statements. exclusive, access exclusive, maybe. Oh, there is something called access exclusive. Oh, wait, access share. So let me send you something. So this one describes the locks supported by Postgres. And the share row exclusive lock is blocking the updates, but it looks like it allows reads.
Yep, okay. So maybe that kind of just solves the read queuing. And then if that's the case, like this seems like a pretty good solution to avoid any locking mechanism either implemented in our application or in a proxy layer.
Yeah, and I mean, you can start with this lock, and at the end, when you finished with the syncing, you can say, okay, now I need exclusive lock because I'm modifying something on the table, renaming it, adding the trigger, whatever, and for a short period of time, it's fine. So yeah, this might
Can you say that again? What when you
so
finish with this
when
lock?
you are in a when you are in a transaction, the locks are kept until the transaction is finished. So first you say, I want this not so a lock that is not blocking the reads, right? So you acquire that lock, you make the record syncing. There are no more updates happening on the table, and when you are done, you still need a way to block the updates on the original table, right? And in that case, you say, okay, now I need an exclusive lock. I rename my original table so everything fails and retries.
All right. In order to rename a table, you need an exclusive lock.
Yeah, for example. And that's, I mean, that will trigger the error that I talked about earlier, and then we could do the reconnect procedure.
Yep, that makes sense to me. Basically, all of these approaches we're talking about requires somebody reading from the database to have a downtime. There is a bit odd, but that maybe because I would have kind of thought we could avoid that, but maybe in this situation, like what you described there, the client performing a read is getting an error, is a situation that we could theoretically avoid with a non-Postgres lock-based mechanism. I think. You're muted.
Sorry, I mean, in that case, yeah, the application would block until the database finish, and then the block in Redis or whatever it's released, and then everything continues as normal. That's what you mean, right?
I was saying that the approach we're talking about now, using a Postgres locking and table renaming, it requires somebody reading from the database to have a read downtime, which may only manifest to the user as latency because we're going to retry that failure. But I would have thought theoretically there will be approaches that involve no read downtime. It's not, but write downtime for sure during a failover.
Yeah.
Like an approach that we talked about, like with our lock implementing an application type locks require no read downtime.
Yeah, so an idea for that, it's already getting crazy. So there is, I haven't tested this. So there is this concept of foreign data wrappers, right?
Right. Okay.
So actually you can mount a foreign database table in your database and then query that. And then you can just plug it in. So you rename the original table and you say, okay, now I have this foreign table. And all the reads.
Now that I think about it, it actually doesn't really matter because we could, if we don't rename the tables, but we just have add the trigger, like you said, such that writes fail, then there will be no read downtime. They'll just get slightly out of date data, which is totally fine anyway, because slightly out of date data is what we're used to in this replicated reads go to a replica situation anyway.
Yeah, and I mean that's a good point, and nothing stops us that after we switch over to set up a reverse sync of data, right? A reverse replication. I don't know if that would work out of the box, but we could keep the original table up to date.
Right, yeah, we'll reverse the
new
replication
table
direction, keep the original database up to date. Yeah, that might be part of this transaction. You add the trigger, then you set up the reverse replication. Now you close the transaction. Now I feel like I'm describing something I just read recently about something else, because that feels like maybe I was reading that in Petroni docs or something, that's kind of how it works, or I'm totally imagining it. In any case, yeah, okay, so this has, what you're describing, all this stuff with the Postgres transactions and Postgres locking has a neat advantage that we don't need to implement a proxy layer. We don't need to implement in-application locking, and we don't need to wrap all our writing code with this in-app locking, which is potentially error prone. Like there's no guarantee with any in-application locking in a distributed system that we could add, where there will be a guarantee because there's a single primary that is accepting writes.
Yeah, I mean, yeah, but this is a process for one table. How do we do it for the CI tables, right?
Yeah, does it generalize? I would have thought that we would just, that transaction would do all of the tables and put the.
I guess that's a possibility. The question is, yeah, I mean, if we can squeeze it into one transaction, then that would probably work, I would say.
But is it possible that we will just never acquire this lock for all the tables?
It's very unlikely that we cannot acquire a lock. So we have a helper method in for the migrations called with lock retries, and what it does is tries to acquire the lock and retries if it cannot acquire the lock. There is one problem with
we
Postgres.
need retries because of the 15-second timeout limit, but
it's not just that. So when you say I want exclusive lock, then your request is going into a queue where the other process is requesting that specific locks. And if you say I need exclusive lock, every other process that requests any kinds of lock will be behind you, and they cannot proceed. So you are like a giant block for everything else. So if you have many statements before your exclusive lock, you can actually ruin the system performance easily, because your exclusive lock will block all the reads already without acquiring the locks. I don't know if
before you've even acquired the lock.
Yeah, you don't even have the locks. You are sitting in a queue, but Postgres says, there is someone waiting for exclusive lock, so you shut up and you wait for your turn. So that's why we have this retry mechanism.
Maybe with our share row exclusive lock, that won't be a problem.
Yeah, but every, like in our migrations, every table modification method, that even renaming a table, any kinds of metadata adding columns requires an exclusive lock, and that's why we needed this helper.
Yeah. I'm trying to map it onto the current problem though, whether or not what it will look like when we try to, even during the quietest period for GitLab.com, what it's going to look like when we try to acquire this share row exclusive lock for every CI table at the same time.
Yeah, so I guess if we might face problems if we have long update, insert, or delete queries. That might be a problem. But this helper, what we have, I think we could easily use it today to lock multiple tables with a specific lock. So
Mm-hmm.
if if we really want, we could actually make a test and see how long does it take just for fun. Yeah.
What will this test impact on production? You're saying running against our live system that's receiving writes and seeing how long it takes to acquire?
It doesn't have significant effect because we set a configuration called lock timeout, which means you are in the queue, wait until a few milliseconds, and if you cannot get the lock, just get out of the queue. So you don't lock and you just retry. So ideally, it doesn't have any effect on the write performance. Very minimal, maybe.
I'm just thinking in my head, if you didn't wait in the queue to get this lock, I just can't imagine that there's an instant in time where you can ask for a lock for every CI table such that none of them are receiving a write at when you asked. To me, I don't know, maybe I'm not super familiar with how this concurrency stuff works in Postgres, but I'm imagining the actual live system. If we want to ask Postgres and say, like, here's the 50 tables, which are some of the highest write tables in Postgres, the chance that we happen to get an instant in time of a few millisecond window or whatever you're saying, where Postgres is not receiving a write for any of those tables seems zero. And so therefore I would think the only way to get such a lock will be that we wait and ask Postgres to just start queuing all the writes behind this. And then we need to go. And then the benchmarking experiment is, how long did it take us to get that lock and how much just queued up behind it?
Yeah, I understand that, and it's probably, I'm not sure, to be honest. It's hard to tell, but what I would do is I would prioritize the tables and get the ones that are getting the most traffic as the last ones, right? So you start blocking the tables that are not getting heavy traffic, and then the last time you just get the lock for the CI builds or CI pipelines. And then you don't start to look at the big tables before getting all the necessary locks for the smaller tables.
Is there like some kind of a deadlocking scenario there where somebody's trying to update another one of those tables after they just started updating the first table?
Yeah, there could be deadlocks though. So yeah,
that's... like I create a pipeline and then I try to create a build, but you've already acquired a lock on build, and now I can't create my build, so now I'm waiting for you and you're waiting for me forever.
Yeah, that's true. Yeah, that can happen. Deadlocks can happen, but there is a deadlock timeout, so it would just probably abort the transaction. But yeah, you are right. If it would be great if we could get the
well, this is why I'm imagining if we find any one of these scenarios, they will happen and we'll never acquire a lock.
Yeah.
Like if we get partway through that chain of escalating locks and we have to abort.
Yeah. Then yeah. I wonder if we can do it in one statement. So it's like
that's what in my head I was thinking first. We could ask Postgres for the lock for all tables, but I actually don't know the syntax and whether that's part of the like multiple tables.
Table looks like it's one. Only supports one.
Okay. Where is the what is the actual Postgres function name that we use for this? Lock?
For locking.
Is it just lock?
So there are two things. There is something called explicit locking. You execute a command and Postgres will figure out what lock does it need.
Yeah.
And you can do this manually with the lock command. So lock table name, and then you specify the mode.
Yeah, okay. So I'm just reading the documentation. So what I think what you're saying is lock table films in share row exclusive mode.
Yeah.
We're talking about we're gonna have a transaction, we're gonna do this, and then we're gonna do our own stuff after that. But and now so therefore what we're looking at documentation wise is this lock table command doesn't support multiple tables, and
yeah. Yep.
Star mean? Does that mean more than one table?
Yeah, I don't think it supports multiple tables.
This okay, it says lock table AB is equivalent to lock table A colon semicolon lock table B. So it does support multiple tables, but it's just like doing them sequentially, like one by one in order. So that's exactly what we don't want.
Yeah, that's not good.
Yeah, I'm trying to make sense of, like, we're thinking about it in detail for Postgres locking, but is all of the concern I have about never being able to lock actually more just an artifact of fundamentally we will need to wait a long time to lock no matter how we implement this, whether this is a shared exclusive lock in, let's say, a proxy interface that it is between GitLab and PG Bouncer, some kind of hypothetical proxy. It will have write queries in progress, and those write queries will need to obtain a shared lock in order to write. Every one of those obtaining a shared lock would still have the same amount of time we need to wait for an exclusive lock from that proxy layer as we would from Postgres. And we'll just need to deal with the fact that we have to have a very large timeout for this Postgres lock in order, and Postgres starts queuing those writes behind that lock request. But because it's a share row exclusive, it won't be queuing reads, they'll keep happening. Does that make sense? Or
Can you repeat it?
Yeah, so I'm wondering about the concern I have about how difficult it is to lock all of the CI tables concurrently. I'm wondering if it makes any difference whether we use Postgres locking or if we implement the locking some other way. Because the concern I have right now is if you tried to do lock table A, lock table B, and you had a short timeout on that statement, it will always time out and you'll never get all the way through all 50 tables we need to lock. But if we have a timeout of 10 minutes, let's say we think it might take that long to get this lock, then maybe that 10 minutes is the same amount of time it would take even if we implemented this locking somewhere else.
Yeah, but 10 minutes is already a bit, blocking writes for 10 minutes.
Well, this is something we're going to have to do one time.
Yeah,
so
yeah.
I think
when
we talked about,
this will be a controlled event anyway, so I would expect this would happen over the weekend. So the chances of getting the lock is actually, it's much higher. I don't say it's impossible or possible, because to be honest, I don't know. We would probably have to try it first, so if we can actually acquire the lock.
My assumption, and I could totally be wrong, but I would assume that even over the weekend, if you tried to run this lock table with the full list of CI tables with a 15-second timeout, it will time out. And if you had a retry that said, I'm going to retry that 15-second timeout 1,000 times in a row, it will time out every single time. Because it needs to sequentially go through them one at a time and get that. And then, but when you start to get to the busy table, so let's say we ordered this by priority. Once you start to get to busy tables, there will be 10 of them. And the deadlock situation will happen, or some other situation will happen such that you will never get it done in 15 seconds. I don't know, that's just my guess. And if you never get it done in 15 seconds, we need to, it would be really nice to benchmark how long it took us to get this done, but we can't do that without interruption to the service. If we want to increase the timeout beyond 15 seconds, But we can certainly try the experiment which you first suggested, which is let's try retrying to acquire these locks over again with a small timeout. But my assumption is that will yield, no, the timeout needs to be longer. And even after 1,000 retries, we don't get all the locks, but I don't know, I might be wrong.
Yeah, that's totally possible. I mean, I don't, usually with one tables, the experience is that for high traffic tables, we will have to retry a few times to get the lock. And when it fails is when we have a long running transactions, and these are popping up from time to time. Like, I don't know, deleting a project takes several minutes, and then of course we cannot get the exclusive lock, and even if we retry, it's not never going to happen.
And these timeouts 15 seconds that you're talking about right now in our migrations.
Yeah, but this retry mechanism, it's actually can run until an hour.
Yep.
Because it's not running in as one statement. Yeah. So what we do is give me the lock. If you cannot get the lock in 1 millisecond, then we sleep in Ruby and we try it again. So this can actually take quite a long time to finish this retry helper I was talking about.
I'm thinking about the maths of extrapolating that to 50 tables. So, or let's say you have one busy table. Let's say of our 50 tables, 10 of them are busy tables. If you compound that failure rate and say, like, let's say you have a 10% chance of getting your lock for one busy table, then 10 busy tables means that you have 0.1 to the power of 10 chance of getting that lock.
These are not these are independent events, not though, right? But yeah,
they're independent. No, they're not independent in the sense we need to get all of them at the same time.
Yeah. True.
We need to, I don't know, like it's like rolling a six times in a row, whatever.
Yeah.
That's the scenario we need to happen in order to. I was trying to actually get that answer, like, but yeah. Anyway, yeah, we'll go 0.1 to the power of 10. What have I got? Oh, 10 to the minus 1 to the minus 10. Yes. So the chance that we get that.
Yeah, I get it, and the question is the busy tables, right?
Yeah, how busy are those tables, and what do those prior percentages look like that we know from existing data? Then we just multiply those percentages together, and we go, okay, that's how infrequently we will be able to acquire that lock, and therefore that's how many retries we need to theoretically do.
We have a list of high traffic tables somewhere. It's not the most up to date, but we refresh it from time to time. So yeah, we have a few CI tables.
Right. Yes, that is
eight tables.
And those, and in your experience, what is the usual number of retries needed before you get a lock on one of those? Do you have that?
So that's
data?
the thing. We are not really modifying these tables anymore.
Okay.
But when I introduced the helper, I tried to collect some data about it. I tried to get it. It's probably not the best format, but I was collecting the migrations, and yeah, I was just wrote down which iteration we succeeded. So how many times we retried, and what was the lock timeout. And yeah, let me see. I mean, for busy tables, like I don't know, issues table, we had to do 6 iterations to get the logs.
Okay, so 1 in 6 chance, let's say,
Yeah.
and then we have 8 tables. So, okay.
Yeah. For projects, 8 iterations.
So you might just probably poorly do this maths, but if I want to acquire the lock for all of those tables, it's going to take me 1.6 million attempts. So this is just, I'll just show you what I just did, but, and it might be, maybe I don't have the statistics exactly right here, but my assumption is like, say it's a 1 in 6 chance that you'll get the lock, and then you need to do that 8 times in a row, then, you know, the chance that you'll get the lock is that, and then we just take 1 divided by that for how long, how many attempts it will take, you know, the average number of attempts it'll take to get that lock.
Mm-hmm.
That's not exactly statistically the right way to do that math, but just roughly that's, I think, still indicative.
Yeah, also you are also not dealing with like, okay, give me the lock. No, you cannot get it, right? So there is a timeout period, like a few milliseconds, a few hundred milliseconds we wait for the lock. So maybe we can get the lock if we get the lock timeout to 1 second. So we wait for the lock, but then we might be able to do that. It would be, I would be very curious to actually measure this.
Yeah, so that's what I was going to write this down as an actual action we can take. So an experiment we want to run is we want to run lock table. I don't know what the syntax was this, but we want to grab all 3 of these table names. So we want to lock all 3 of these tables. And I'll fix the syntax in a second in Vim, but then we want to do that with this in share row exclusive mode. Okay, let me fix that up. We want to run that on the weekend, right?
Yeah, that would be pretty safe, yeah.
And we will do that with progressively increasing timeouts up to a reasonable threshold such that we shouldn't get
yeah, this is done automatically by the helper.
Okay, so this, and we trust that the helper is not going to do something too large that will cause serious degradation. It will give up if this, it will give up before getting to a stupidly large number.
Define stupidly large number.
Well,
we can optionally configure our own timing, so that's possible.
Well, I just mean if we tried to do this with a 10-minute timeout, then that will mean that we're queuing up 10 minutes worth of writes while we're acquiring this lock, and that will be very bad.
Yeah. That's true. Yeah, I would say we will need a custom timing, because at the end, so what I try to implement with this helper is some sort of exponential retries or exponential backoff. So first we start with really slow timings, and then we slowly increase, and sometimes we do jumps just to see if we can get it. But if you configure it in a way that, you know, the timeouts are under 1 second, under 5 seconds, then it should be pretty safe to do. These are the timings here. So this one, the timings, and this is we can override it easily. So it's an array which contains the statement that what is it? The sleep time in Ruby and the lock timeout. What we wait for this is the time we wait for the locks.
Yeah, we just need it to, okay, so it goes up to 10 minutes, and we don't want to go up to 10 minutes.
Yeah, we can configure this, so it's not a big problem to customize it. So yeah, I would say we should keep it under 1 second, under 5 seconds, and that's very safe. I would say that's a safe approach.
Okay, so I've written that down. That's something we can action, and we think this is pretty important for us to action because without this, we can't really answer the question if Postgres can provide us the locking. This can help us understand if Postgres can provide us the locking mechanism really easily. If we get 5 seconds, we get this done in under 5 seconds, that's all of a sudden, okay, this is a promising approach.
Yeah.
Which turns out to be quite simple with minimal service disruption. Otherwise, if this approach is not promising, then things start to look more like, okay, the service disruption will probably be on the order of minutes or maybe an hour. I think it's also totally, I don't know, given we're going to be doing this one time, I think, yes, it's a planned event on a weekend. I think we can possibly consider treating this a little bit like the PG12 upgrade in that, like, this is so critical that we might have to take an hour downtime for part of the application of GitLab. If we could do that.
Yeah. I mean, that would be the last resort, right? If we cannot make this work without downtime, then we need to schedule a downtime for it.
Yeah, in thinking about it, GitLab's not going to be good at handling partial downtime because things like a git push need to trigger creation of a pipeline. And we do not want people to be able to push and then wonder why they never got a pipeline. And there may be much more serious consequences than the ones I'm describing.
Yeah. So there is no partial downtime. It's the application was never built, so it was not built in a way to handle such things. So downtime is downtime.
Okay. Cool. Any other interesting things we want to discuss now?
So the replication. So how do we actually move that 5 terabyte or whatever number data from one node to another? We can send Fabian to the data center to switch the hard drives, but this is I don't have a good solution for this. We can do the standard Rails migration stuff, which means we get the data from the database, to the original database in Ruby, and then insert it into the new database.
That seems completely infeasible. I just couldn't even imagine Ruby keeping up with that task, right? Like, if we have writes from hundreds of concurrent Rails nodes in Sidekick and various other places, I can't imagine a single Sidekick process being able to keep up with replicating all of those writes somewhere else.
I mean, how would it work? First, we would kick off a background migration that basically copies the table to the new, so copies the data to the new database. So this runs in the background. And yeah, as you said, what we do is take, I don't know, 100,000 records from the table and load it in Ruby and construct an insert statement for the other database and then execute the insert statement. So basically that 5 terabyte will touch the Ruby node and it will go to the database, right?
Yeah. I mean, I'd happy to do benchmarking on it, but my initial instinct tells me that route is not going to work. Like, just Ruby, the amount of CPU it will need to do that work, even if you just assume it, like, there's so many inefficiencies in that. For one, just over the wire reads, marshalling into Ruby objects, marshalling into SQL statements and writes somewhere else. But those aside, just the actual, just the Ruby single-threaded process capable of doing that, I couldn't imagine it could be possible.
I somewhat agree. I mean, we can optimize it so we don't have to use active record for it. We can use a lower level construct. Also, the good thing, what can help us is the fact that the tables have a primary key, which means based on the primary key, you can create batches, right? So based on the ID ranges, you create batches, and each batch can be migrated independently, which means you can parallelize this process. So you can have 10 Sidekick workers inserting stuff to the new database if you really want. But yeah, I agree, this is still sounds a bit inefficient. But if you think about the other approach where we say, okay, let's set up logical replication, then everything happens between two databases. You need connectivity for sure between these two databases, plus on self-managed or self-hosted, it might not be feasible. I mean,
Yeah.
okay, let's not look at self-managed, but
yeah. That's exactly where I don't want to go down that road, because I totally agree with you. Like, but I also have a suspicion that any implementation we make that will easily ship to self-managed won't be appropriate to run for GitLab.com. And I also feel like if we just remove that constraint from our problem space, we'll eventually come back and solve that problem once we've that's the only other thing I'm thinking. But yeah, I don't know, my instinct tells me that reading in Ruby is incredibly fraud. But part of that is Ruby itself and the Rails application, but we could get around that with, say, we just delegate that work to a Go executable that runs in a Sidekick process. This is partly how Elasticsearch indexing works. It's like a lot of the marshalling of Ruby objects was just too expensive in Ruby. And so we just did it in Go and we just shell out from Sidekick. So that would be a way to think about this. But I also think we want massive concurrency to keep up with this workload.
Yeah.
Maybe I'm wrong about that too.
Another idea, I haven't validated this. So assuming, so I don't know if you read that proposal I had with the idea of using triggers to keep track of the changes, right? So assuming if we have that in place, what we can do as the first step is just dump the tables, export, right? And then import it into the other database.
Yeah.
So then you don't need replication, you don't need Ruby, you just need to move a few files to the other node and execute the import command, right? And that's actually pretty fast.
Hold on, sorry. With using the table migration changes model, how do we trigger the writes? Do we trigger them as a single SQL query? And that's why you're saying Ruby won't be reading and writing any data. It'll just.
So it has two functions. So first is this changes table is just to keep track of the changes since we started the migration, right? So this is what we pick up later when we actually are about to switch the tables, right? So this is just a change log. And then when we place those triggers, we just say, okay, just dump the table, the current state, I don't care. The changes are already stored somewhere else. So dump the table, you have a dump, which is, I don't know, a few minutes old or a few hours old, doesn't matter when it's finishing. Most of the data will be there and up to date. You just move it to the other node and import it. And then later you apply the changes from that changes table, assuming that changes will not be crazy big.
That makes total sense to me, but I think it's exactly the same as logical replication, because that's basically what you'll need to do with logical replication anyway.
Exactly. But
the thing I was latching onto there was, how does it differ from the Ruby side? How does one use this table migration changes table?
So that's still in Ruby, but we assume that the number of records there will not be as much as the whole table. So if we have 5 billion rows currently in the table, if we can get the data into the new database, we might have a few million records of changes, maybe 10, 20 million. Those are still manageable.
Yeah, my assertion is it's not the volume at a point in time that's going to be unmanageable. It's going to be the rate that's unmanageable in a single threaded Ruby process. So your table migration changes table is constantly growing, and so the concern I've had that I had before in terms of whether it's a Rails background migration, reading and writing, is the same here in that this table will just constantly be growing at the rate. So let's say we have 100 Rails nodes that are performing writes to Postgres at one point in time. There's going to be one single node that is trying to replay all of those at the same rate, and it will always fall behind.
And this can be improved with parallel execution, right? So you can insert from two threads. But basically, if we talk about the switchover, if we have this table, we can probably measure the lag, right? How much we are behind, right? Because as you move stuff from this changes table, you will also delete them, right? Because you are already
it's the same thing in logical replication.
Exactly. Yeah. But you have with logical replication, I don't know if you can say something that, okay, stop and just migrate everything now. I don't know if you can do this.
Yeah, that's what it's doing. I mean, when you set up there's different ways to use it, but if you set up the subscription and publication, it will do an initial PG dump type approach to copying all the data across and only updates since. And so, yeah, with logical replication and the way that I looked at it before is like you create a snapshot in Postgres and you say, Postgres, give me at this point in time, this transaction, give me a dump of what the database looks like then. And then concurrently, all updates that have happened since, make sure they're added to this stream of updates called the replication slot. And we'll consume those later. So that architecturally, they're pretty much identical. You're just using a table called table migration changes as the replication slot.
But the question is that at the end, so let's say you are about to switch the tables, you want to switch the connection. Can you do it with replication? Can you do it that, okay, whatever is left, replicate it now, block the execution, and give me the control, so I can switch the connection.
So basically what you would say is you would acquire the lock in a transaction, and you would find out the transaction ID of when you acquired that lock, and then you would only need to consume the replication slot up until that point. Well, the replication slot there would be nothing getting written to the replication slot if you did acquire a lock that prevented writes as well. So yeah, I think they are the same. And you'll have all the same tools like the replication slot. You can look at the latency of the replication slot by just comparing the, I forget what the LSN or something like that was.
LSN something. Yeah.
So by comparing those things, you'll end up being able to do the same thing as basically count star of this table, right? That same effective.
It's pretty much
in any case, the task the thing that would do the copying I think we would choose to use a very fast processing that would not be a Rails sidekick worker written Ruby doing an active record find with the primary key, etc.
I think the best option I see now is setting up logical replication. I mean, it deals with the inserts and everything up to date by itself. We can probably speed it up if we don't create the indexes right away on the new table, because then the insert speed will be very fast.
My thinking is that we need to explore this. I agree, logical replication is a way to do this, but I think we need to explore the fact that we already have replication with Patroni and we already have up-to-date replicas. And if we can exploit that, and since Patroni is supposedly faster than logical replication, because I've been told that we couldn't really use logical replication because of the volume, and Patroni is based on physical replication, I think, then we have this replica that already has all of the CI tables. We just need to fail over to it and make us, treat that as another CI logical database and delete all the other tables at some point in future.
That would work, but that means we need to change that database after the switchover, right? Delete the tables, removing it from the
I think we'll first need to like remove it
Yeah.
from Patroni somehow and just say like Patroni,
Yeah,
this
yeah.
is no longer a thing that is in your
Mhm.
cluster anymore. And then we kind of manage that database somehow ourselves. I think at this point, like the detail I'm getting into is like I don't know enough about Patroni, and I think we'll probably just end up having to talk to the DBREs, etc., about this plan. But to me, this seems like the most promising in terms of the fastest way to do this task because we don't need to do an
Yeah.
initial copy; it's already up to date, and there may already be a replication protocol that's fast enough to keep up with the updates, such that we don't even need to create a logical replication.
Yeah. That's very good. And to be honest, adding a new node or new nodes to Patroni, I think it's a standard procedure. So it's not something that needs very special research. It's
Yeah,
just
exactly.
add us, I don't know, 4 or 5 new nodes, and that will be the new CI cluster. We just replicate to one node and then slowly build up a new cluster.
Yeah, it's almost like we're deliberately trying to create a split brain cluster situation in Patroni. It's like now split and you form your own cluster over here and you think you are the correct place for CI tables, etc. And I think even something like this might be combined with actually several of the tricks that we've just talked about now that you mentioned, like with the transaction and creating the locks and the triggers. These tricks actually may all be useful even in that case because the initial triggers might be like make it so it's impossible to write to all of the tables that aren't CI tables. And that's the way we prevent any possible weird situation where somebody has a connection to the wrong now CI logical database. But Patroni kept these up to date and helped us with the failover.
Yeah, that's good. That's really good.
Okay, well, this has been a pretty long chat already, and it's kind of getting to the end of my day. But I think, yeah, probably my next step is I'm going to just keep learning about Patroni and figure out what configuration options it has, and then whether or not we can do any of this stuff. I think the other thing we wrote down about doing this experiment for acquiring these locks is a useful exercise because that will, if this Postgres locking mechanism works, this actually saves us trying to figure out how to do the locking somewhere else. Like, I imagine Patroni is going to have a lock failover with lock type thing built into it. But I suspect whatever that looks like in Patroni's code is not going to work for us because Patroni is not likely going to have a feature where it understands the idea of failover for a subset of tables, which is what we need. And therefore, we're going to need to implement our own lock like this. So this is a good tool that saves us either implementing a proxy layer or some other in-application code or something else.
Yeah, that's cool. Okay. And I see Fabian already pinged someone in the thread.
Yeah, and I think he's just sort of saying a similar thing to what we're talking about, the fact that we're doing something similar with Geo as well. So maybe this will be a good approach to go down, and maybe the people pinged on there will actually be able to articulate what the architecture looks like in terms of the features we need. Okay, all right then.
All right.